Hello. Uh, in this video, we will look at multiplication and division of rational expressions. Uh, Multiplication with fractions is the simplest of the four basic operations. And we have seen that multiplication of fraction is a simple form of multiplication of rational expressions. We know that if you have A over B times C over D, each one of this here is a fraction. And when we multiply, this is equal to A times C. We multiply the numerator. So A times C divided by, we also multiply the denominator. And this becomes B times D. Okay. So when we multiply, that's generally what we do. And you will see sometime we also have to simplify, okay, by factoring terms. And then for division, if we have A over B divided by C over D, first we have to switch that sign, A over B, the division sign, okay, has to be converted to a multiplication sign. But when you do that, this fraction to the right of the division sign flips. So this becomes D over C. And then we can multiply. So we have A times D now, yeah, divided by B times C. And that's also a multiplication that we've done there. So we can't really perform division unless we convert it to a multiplication. Okay. So those are the two general ideas that we will use for this lesson. Okay. Also, we had multiply here, right? Now you have seen this. You have seen this in fractions. Okay. So with fractions, if you have, let's say, 6 over 7 times 14 over 18. Well, there are two ways you can do this. Okay, you can multiply 6 times 14. So here we have 6 times 14 divided by 7 times 18. We multiply them. Then what we do, we can simplify the numerator and denominator. So if you notice that 7 and 14 can be reduced, okay? So we can say 7 divided by 7 is 1, and 14 divided by 7 is 2. And then we also can simplify 6 and 18. Okay, what number go into 6 and what number goes into 18? Well, 6 divided by 6 is also 1, and 18 divided by 6 is 3. So this leaves us with 2 over 3. So that's one way. Okay. In addition, what some of you had learned was to cross reduce, right? Some of you had learned how to cross reduce. And what do I mean by that? Let's give it some more room, so at least you will. What we do, we divide, okay? We'll divide here by 6. We can divide by 3, because if you want to divide by 2, you could, right? If you divide here by 2 and this by 2, 18 divided by 2 becomes 9. 6 divided by 2 is 3. Yeah. So we have here 3 over 7 times 14 over 9. Okay. Now, if you look at that again, if you look at that, 3 over 7 times 14 over 9, right? You can divide here of 14 over 9. You can also divide here again by 3 and this by 3. And 3 divided by 3 is 1, and 9 divided by 3 is 3. So you can go 2 and then try 3, or you could have tried 6 and then you would have to only do it once. So if we do this, what do we have now? 1 over 7 times 14 over 3. So if we write that back, 1 over 7 times 14 over 3. And then if you look at this again, you can divide here by 7 and divide here by 7. So 7 divided by 7 is 1. 14 divided by 7 is 2. So that leaves you with 1 over 1 times 2 over 3. And if you multiply 1 over 1 times 2 over 3, this is equal to 2 over 3. So some of you know how to what is called cross simplifying, right? So there are many ways that this can be done. Okay, well, a few ways. Now, the whole idea of simplifying rational expression or multiplying rational expression is the same. Now, we had looked at a video of simplifying rational expression, so that will help you a lot with this section. So if I give you an example and I say to multiply, okay? So if we have 8x cubed divided by 27y to the 8th times 9y cubed over 12x squared. So we can use either of the approaches we did before, right? So what you can do first, and remember, right, we can only simplify any top with any bottom, okay? We can always simplify, we can always simplify or reduce any numerator, meaning a top, with any denominator, meaning a bottom. You can never reduce two tops or two bottoms. Okay. So if we rewrite our problem, 8x cubed over 27y to the 8th times 9y cubed over 12x squared. Okay. Let's look at the 8 and the 12 first. What number goes into 8 and 12 evenly? Well, if you think of 4, right? If you divide here by 4, and you divide this by 4, this will become a 2, and this will become a 3. So that leaves me with 2x cubed over 27y to the 8 times 9y cubed over 3x squared. Okay. Now, if you pay attention again, I can simplify this. I can simplify this 9 and this 3 because it's a top and a bottom. I can divide both terms by 3. Yeah? I can divide both terms by 3. If I divide this by 3 and this by 3, this here will simplify and this here will simplify to both. This becomes a 1, yeah, and this becomes a 3. So what do I have now? I have 2x cubed over 27y to the 8 times 3y cubed over 1x squared. And I'm not looking at the letters right now, only the numbers. Once again, I have a simplification here. Okay, I have this 3 and this 27, a top and a bottom. So I can divide both numbers by 3. I can divide here by 3 and 27 divided by 3. Okay, so this becomes a 9 and this becomes a 1. So in terms of the numbers, I have 2x cubed over 9y cubed times 3. No, it wasn't a 3, it became a 1, right? 1y cubed over 1x squared. There's no number that can be simplified anymore, right? There's a 2 in the top. There's no factor of 2 in the bottom. I'm sorry, there's no multiple of 2 in the denominator. Okay? So 2 doesn't go into 9. 2 doesn't go into 1 evenly. And then there's a 1 in the top. There is no 1. So we can rewrite this without the 1's. So this is 2x cubed over 9y cubed times y cubed over x squared, because we don't need to write these 1's here. We don't really need to write them. Now let's look at the letters. Remember, when we're dividing, if the bases are the same, they can be simplified. So it means that I can simplify this by x cubed with this x squared, any top with any bottom. Okay? And I can also simplify this y cube and this y cube. So if we look at this, x cubed divided by x squared, that is just equal to x. 3 minus 2, which is x to the 1, which is just x. And then y cubed divided by y cubed, this is equal to 1. Anything divided by itself is 1. So when we simplify, we will have 2 over 9 x times 1, which is the same as 2x over 9, or 2 over 9 times x. Well, let's see if that is correct. So I noticed that what I did here was y to the 8th, and here I wrote y to the 3rd, right? So this should have been y to the 8th. Okay, this should have been y to the 8. And if I do that, then this here is not 1. This becomes y3 minus 8, which is equal to y to the minus 5th. So this should be y to the minus 5th. And now, if you do that, okay, remember y to the minus 5th can be rewritten. So we have 2 times x, 2 over 9, times 1 over y to the positive 5. Okay. And if we multiply this out, we have 2x over 9y to the 5th. So it looks kind of long because I've showed step by step each number then each letter. So generally you can combine steps and they are much shorter. Okay. So the problem may look very long this way. Now, the whole idea of simplifying is really a process of factoring. Okay. So if you look at my next example, multiply, and remember, if you know multiplication well, then division is the same thing. So if we have x minus 3 divided by x squared minus 4 times x plus 2 over x squared minus 6x plus 9. So if you're good at factoring, then you can go ahead and factor each numerator and each denominator. Okay. So you want to try to factor this if you can. Then you want to try to factor this if you can. Then you also want to try to factor this part here if you can, and factor this here if you can. Okay. So you want to write them as factors. Now, so what I like to do is forget about the whole multiplication. Okay, we want to factor. Can we factor the top, which is x minus 3? And then we want to also factor the bottom. Okay, so this is the left half of the problem, which is x squared minus 4. Well, there is no GCF here. Okay, there's no GCF here, so this cannot be factored. But if you look at this one here, okay, this can be factored because it's the same as x squared minus 2 squared, which is x minus 2 times x plus 2. Okay, difference of squares. So we do the same thing for the right side. Can we factor the top? And then can we factor top? Can we factor the bottom, which is x squared minus 6x plus 9? Well, once again, for this example, the top cannot be factored, okay? But the bottom can be factored. It's a polynomial. So if we factor this bottom, our 2 binomial becomes x minus 3 times x minus 3. Okay? So our problem is the same as x minus 3 divided by x minus 2 times x plus 2 times x plus 2 divided by x minus 3 times x plus 3. Okay. All I did here was that I factored the denominator. Okay. I factored this, and I also factored this here. That's all I did. Okay. If you look at the two problems here. So this here is the same as this here. Okay. Same problems. Just one of them is in factored form. Now what we're gonna do is to reduce, cancel, okay, numerators from denominators. So notice this x minus 3 can be simplified or cancelled with that x minus 3. So we look at the top again. There's a x plus 2 in the top, and there's also a x plus 2 in the bottom. So this x plus 2 can cancel with that x plus 2. And there's nothing in the top other than a 1. So what I'm left with here is 1 over x minus 2 times 1 over x plus 3. So be careful. Although when you cancel this, it doesn't mean nothing is left. There is a 1 there, okay? And now if you multiply, you have 1 times 1 over x minus 2 times x plus 3. But 1 times 1 is the same as 1. So 1 over x minus 2 times x plus 3 is our final answer. Okay. So as you see here, the factoring is the whole idea, right? Now, this step here was just sort of a scrap work step to show you what I'm doing, right? But you can also do this in your work so you see what you're doing. And once you master this, then you'll be able probably to do the factoring in your head. But if this is new to you, I would suggest that you write each part out individually. My next example. Okay. Example. Multiply, okay, 2y squared minus 4y divided by 2y squared minus 2 times y squared minus 2y minus 3 divided by y squared minus 5y plus 6. Now always check, right? Always check to see what sign that is. It is multiplication, so we don't have to do anything other than simplify. So I'll use the same idea as we did before. We want to factor the top, and then we want to factor the bottom. And that's for the left side. Okay? So the top we know is 2y squared minus 4y. The bottom we know is 2y squared minus 2. So notice I can factor GCF is 2y. So if I take out 2y, I have y minus 2. Okay? GCF. GCF we have here also is equal to 2. So if we take out a 2, we have y squared minus 1. But be careful with this. That's the difference of squares, right? It's the same as 2y squared minus 1 squared. And this here we know becomes y minus 1 times y plus 1. Don't forget the 2. The 2 comes down. So we factor the top, we factor the bottom. Okay? Now let's look at the right side. If we factor the top, which is y squared minus 2y minus 3, and we now factor the bottom, which is y squared minus 5y plus 6. Well, these are both quadratics, okay? They are both quadratics. So we know that this could possibly factor into the products of two binomials. So we can factor this into two binomials. And if we do this, we should get y minus 3 times y plus 1. Okay? If you have to take a minute and look back at your notes or video on factoring quadratics, then please do so. And then likewise, if we factor this quadratic here, okay, we should get y minus 3 and y minus 2. So now we can rewrite this here with the factors that we've got, okay? So the factors for the first numerator we know is 2y times y minus 2. For the bottom, we have 2 times y minus 1 and y plus 1 times, for the top, we have y minus 3 and y plus 1. And then for the bottom, we have y minus 3 and y minus 2. So please note, right, when you draw the line must be over everything in the top, everything in the bottom, okay? So the line must cover everything in the denominator. Please be careful with that. Now we'll look for like things and cancel them out. Any top with any bottom. So my first cancellation that I see, I have a 2 here, can cancel with a 2 here. Okay? I have a y plus 2 in the top here, and I have a y plus 2 in the top here. Sorry, a y minus 2 in both. So these will cancel with this. Okay? I will rewrite this because it will start to look very confusing. So I have y left in the top here. In the bottom, I have y minus 1, y plus 1. You don't have to rewrite it, but I'm just doing that because it will start looking a lot confusing if I don't leave out some of the terms that I've canceled out. Let's look again, right? So notice here now, I have a y minus 3 and a y minus 3. And then also, if I look again, I have a y plus 1 in the top and a y plus 1 in the bottom. Any top with any bottom. So what do I have left? I have y over y minus 1 times, well, remember I said when they cancel out, you have a 1 over 1 left, right? They just don't cancel out and become 0. And now if I multiply this, I can say this is the same as y over y minus 1. Now, be very careful, right? Be very careful. This is your final answer. If you're thinking, why don't I cancel this y with that y? I can't do that. Because I have a minus 1 attached to this y. You can only cancel things when they're written as product. Okay? So if this was y times 1, then you could cancel it. Okay? So it cannot be canceled. Only when it's written as a product you can cancel. Okay? So let's look at some examples now with division. Right? Division. So now we want to divide. Okay? Let's divide 1 over x squared minus 9 divided by 1 over x squared plus 9. So be very careful. Now we're dealing with a division sign, so we can't do anything. Okay. I always like to change that division sign first because sometimes we forget about it. So the first thing I usually do, I write 1 over x squared minus 9, and I change that division sign to times. But when you do that, don't forget that you have to flip the fraction to the right of the sign. Okay, so this fraction here has to be flipped. Okay, change the sign. Okay, change the sign and flip the fraction. Okay. And now we go through with the same idea as we did before for multiplication. So I'm going to break this into 2. Okay. We want to factor the top. I want to factor the bottom. So the top is 1, so 1 can't be factored. But the bottom, x squared minus 9, is difference of squares. So this becomes x minus 3 times x plus 3. So that's the left side. If we look at the right side, if we factor the top, which is x squared plus 9, be careful, this is a plus, so there is no sum of squares. So this cannot be factored. And then if we look at the bottom, which is 1, that cannot be factored either. So by rewriting our problem in the factored form, we have 1 over x minus 3 times x plus 3, okay, times x squared plus 9 over 1. So notice that there is nothing here that can cancel from any top or any bottom. Well, if you want to say the ones cancel, you can say that. Yeah. So what I'm left with here is x squared plus 9 over x minus 3 times x plus 3. Okay. Or you could have written it as x squared plus 9 over x squared minus 9, either one of them. Okay. So the key here is that you have to change that sign first and then flip. And then it just becomes a multiplication problem, right? It's only a multiplication problem. Let's look at another example. Divide. If we have x squared minus y squared over x squared minus 2xy plus y squared, and I want to divide that now by x cubed plus y cubed divided by x cubed minus x squared y. Okay. So the first thing I want to do, I notice this is division, so I'm going to rewrite my problem using a multiplication. Times, and don't forget I have to flip this guy here. When I do that, I have to flip this. Okay. So now I have the x cubed minus x squared y in the numerator. And in the denominator, I have x cubed plus y cubed. So as I did before, okay, I'm going to factor the top. and I'm going to factor the bottom if possible. Okay? That's the left side of the problem. So the top is x squared minus y squared. The bottom is x squared minus 2xy plus y squared. Okay? So let's see if we can factor this. Well, this here is difference of squares, so this becomes x minus y times x plus y. Oops, x plus y. That's factoring of the top. Now, what does factoring of the bottom gives us? If we factor this bottom here, which is a quadratic form, right, we have x minus y and x minus y. Because a minus y and a minus y give us positive y squared. Okay? So that's my left side. If I look at the right side and I factor the top, which is x cubed minus x squared y, and then I have to factor the bottom, which is x cubed plus y cubed. So that's the cubic form I can see there. Now, on this part here, I can take out x squared, and that will leave me with x minus y. And on x cubed plus y cubed, that's the cubic formula. Okay? That's our cubic formula. So if I simplify that, I know this becomes x plus y times x squared minus xy plus y squared. So if I write these all together now, we have in the top x minus y times x plus y. In the bottom, we have x minus y, x minus y. Remember, we change it to times, so this becomes x squared x minus y. And in the bottom, we have x plus y times x squared minus xy plus y squared. Okay? Now we look for items in the top and similar items in the bottom, and we cancel. Okay? So we have an x minus y here, we have an x minus y there. So that cancels out. We only cancel one in the top with one in the bottom. Okay? Notice we also have an x plus y here and an x plus y there. Okay? So I think I should rewrite this because I don't want it to look, since everything cancels out in the top, that leaves me with a 1. In the bottom we have x minus y. In the top we have x squared x minus y. And in the bottom we have x squared minus xy plus y squared. Okay. We have one more cancellation I see. We have an x minus y here with an x minus y there. Okay. And I think that's all the cancellation we have. So we have 1 over 1 times x squared over x squared minus xy plus y squared. And once again, we said do not cancel this with this because it's not a product in the denominator, it's a difference. Okay. So final answer is x squared over x squared minus xy plus y squared. So as we see here, factoring is very important, right? Now, in my next example, how about if I say perform the operation? I have a squared minus 8a plus 15 over a plus 4 times a plus 2 over a squared minus 5a plus 6 divided by a squared minus 3a minus 10 over a squared plus 2a minus 8. Now the operations we're talking about is multiplication and division. And we know that we cannot really work with division. So the first thing I'm going to do is to change this here. Change. And if I change, I flip the one to the right. Okay. So by doing that, I now have a squared minus 8a plus 15 over a plus 4 times a plus 2 over a squared minus 5a plus 6 times, and now I flip, a squared plus 2a minus 8 over a squared minus 3a minus 10. Now, factoring each part, so you will go and do it on the side. If you factor this, that becomes binomial because it's quadratic. The denominator cannot be factored. Okay? So if you factor that numerator, okay, you should have a minus 5 a minus 5 and a minus 3. Okay, my numerator here cannot be factored, so that stays as a plus 2. But if you factor this denominator, that can be factored. And since it's a quadratic, it will give me 2 binomial. So a squared minus 5a plus 6 can be simplified or factored as a minus 3 and a minus 2. Okay? Times, and then if you factor, if you look at this one here, this can possibly be factored, and this can possibly be factored. Okay, so we want to factor both of them. So if we factor the numerator, we have a minus 4 times a plus 2, and you guys will probably want to do it like I was doing the scrap work, right? I'm just showing you here that I've cut out the scrap. And then the denominator will be a minus 5 and a plus 2. Okay. So now we reduce. Okay. So notice here now, we have an a minus 5 here, which is in the top, and we have an a minus 5 all the way here in the bottom. It doesn't matter how far it is once you simplify a top with a bottom. Okay. We also have an a minus 3 and an a minus 3 here. Okay. I just observed here that there's an error because this here is a plus 2, so we want this here to be different, right? This should be, since that's a plus, it's a plus 4 and a minus 2. I had the signs wrong. Okay. Let's do back our canceling. What else can we cancel? Okay. So we can also cancel. I notice here I have an a plus 2 in the top. So an a plus 2 cancels with an a plus 2. Okay. Let's see what else we can cancel out here. Let's use purple. We have an a plus 4 in the top. We can cancel an a plus 4 in the bottom. There's a lot of canceling. And then we have also an a minus 2 in the top. So we have an a minus 2 in the top, can cancel with this a minus 2 in the bottom. So what do we have left? We have 1 over 1, okay, times 1 over 1 again, times 1 over, 1 again. Everything basically canceled out. So this leaves me with 1 times 1 times 1 over 1 times 1 times 1, which is equal to 1 over 1, and that is equal to 1. And this is the final answer. You cannot say everything cancel out and that's it. Okay? So we don't have to multiply 1 term or 2 terms or 3 terms. Okay? We can also multiply many terms. So as I always say at the end of my videos, you want to practice some more of these types of problems on your own and become better at it. Okay? I'll see you next time.